Hi everyone, I'm Aaron Rupp, and today what we're going to be doing is we're going to be going over how to program a mill hand programmed part from percent sign to percent sign. So what we'll be covering is we'll be going over all three lectures that we cover in our Blackboard. We'll be covering how to start the program, how to do the facing, the profiling, the pocketing, and we're going to be going over holes, and for our hole locations, we're going to be using the third method for trigging out the holes locations. Okay, and then once all that is done, we'll have all of our code, and then we'll show you how it should look like when it's all run. So what I'm going to do right now is I'm going to kind of show you what we're going to be making. So I'm going to teach you how to take this part, and we're going to program all the tool path, and we're not going to do the excess, and I'll explain what the excess is here in just a minute. I'll let that be up to you on how you want to do that. So we're going to be taking just a standard program, and we're going to be going over how to face the part, and then I'll give you a safe start location on how to profile the part. And then after we profile the part, I will teach you how to safely enter the pocket with a ramping style, and I'll be using the zigzag ramping style, and then from there I will show you how to trig out the hole. So again, all of these are going to be found in your programming workbooks. They'll also be found examples in the other lectures, and you can also use this as well. Now yes, you will find all the answers to your program, but please use this video as reference to help you understand how to program, because the next part you program there won't be a video on. So let's get started. So the first thing I want to do is I want to take a, we'll say a 3-inch face mill, and I'm going to go ahead and I'm going to go across this part at Z0. Okay, so the first thing I want to do is I want to come to my part, and I want to start at the percent sign. So the first thing I have at the top of my program will always be a percent sign. Now what that does is it lets the controller, when you input your program into the controller, it says, I'm looking for a percent sign. I'm not looking for a space. The first thing you have at the top of your file is a percent sign. After that, it's looking for a letter O. You are only allowed one letter O per program. So make sure that you'll hear me say M08. I'm going to try to say zeros, but make sure that you always put in zeros from here on out. No more letter O's, okay? So this next code can be from 0, 0, 0, 1, all the way, I'll put this in parentheses, all the way to 7,999,000. Now the reason why is an 8,000 program to 9,000 programs are usually protected programs in your machine. So I don't want anybody using these right here. So I'll go ahead and erase that. Now from here, the first thing we want to do is I like to have a tool description. Now you're going to have a lot of stuff in here as well. You'll have what tools you're going to use. You'll have some descriptions on what's going on, such as like your part 0. So for example, I'll kind of show that a little bit. So up here at the top, I'll have a parentheses. Everything within a parentheses will not read. I'll put X, Y, 0 is bottom left corner. Now keep in mind, all the notes that are in parentheses are for the operator when they're running the machine. Now let me show you why I picked that location. If you look right here, you'll see that I have an origin, okay? That is where all of my dimensions are going to be coming from. So to give you an example, if I wanted to come to this location in X, I will move that dimension over, okay? Because that is the location of this point in relation to origin. That'll make sense as we go around. So back to here, I'll also put on here in parentheses Z0 top of part. Now, if you're thinking, hey, if Z0 is the top of the part and I go across it on Z0, I won't take off any material. I will also show you what to do from there, okay? So I've got a pretty basic start here. I've got my O number, I've got my XY0, which is the bottom left corner of my part, and I got my Z0 as the top of the part. That helps me as I'm programming it, and it helps the operator when they're setting it up. So the next thing I want to put on there is I want to go ahead and call up the tool. However, what I usually like to do in my programs is I give it an M01. What that does is it tells the machine to stop, and it lets me know what's going to happen. So M01, I'll put a tool description. I said a 3-inch face mill, 3-inch. Remember, see this decimal right here? Do not forget about your decimals and their locations, because that can make a big difference. I will also explain that. So I'll just put face mill, and then I'm going to start giving my machine a lot more codes. Here's where you want to start paying attention, all right? This is kind of a basis, but the next few lines I'm going to show you are the several lines that you'll have at the beginning of every tool, all right? So the first thing I'm going to do is I want to call up that tool. That is the first tool in my program. I'm going to give it a T1 M06. All that will go on one line. Then from there, I'm going to go ahead and I'm going to send it to a location. Now, where am I going to send it? I have a 3-inch face mill. If I send it to XY0, it's going to put the center of my tool right over the top of it. So when I come down on top of it, it will slam on top of my part. I don't want to do that. So this would be Y. See if it'll let me write on there. This will be Y plus direction going up. This will be the X plus direction going that direction, all right? So that means I want to put my tool in the X negative direction by more than half the diameter of the tool. So if it's 3 inches, 1 inch 500 thousandths will put the side of my tool right there, okay? So I can also come up. So I'm going to move it up 1 inch as well. I'll move it up about 1 inch. That way I can do this part in 2 passes. I know that it will clean all the way up, okay? So the next thing I'm going to do is I'm going to go rapid G0 absolute G90. We will always program in G90. My work offset, which is my origin location on the machine, and then I'm going to go in X minus 1.5, but maybe I want to go more than that, okay? So I'll just make that 600 thousandths. So 600 thousandths. That way I still don't come down right next to my part. And then I'll put a Y of 1 inch. If I go 1.5, there's a chance that the bottom of my part might not clean up. So I have a 1/2 inch overhang. That'll make a lot more sense as you see it run, all right? So the thing I like to teach people is I've almost got all my starting points. So I'm gonna go to that location, and on this location line, it's up to you. I can turn on my spindle and tell it which direction I'm going, or I can put it on a separate line. For most examples you'll see, the spindle speed goes on this same line. So I will turn this on at 3,000 RPMs, and I'm going to turn on M03. That is a clockwise rotation. The next line I'm going to put on there is my tool now knows where to go in relation to my G54. Now it needs to know how high above the part it needs to go. So it needs to pick up its tool length offset, and to activate the tool length offset, it is a G43. My H has to match my T, so H1, I'm going to give it a Z 1 inch above the part. That is a safe location for beginners. If you want to go 3 inches above the part, you can do that as well. And then on this same line, I want to turn on M08. And of course, like I said, you'll see me forget those lines right there. Just always remember, no more letter O's in my program. So what you see right here is how every tool should look when it starts. right here. So even if the next tool gets done, I'm going to send the tool home. M01, tool description. Call up the correct tool, wrap it to a safe location. I'm still above the part. And then I'm going to move 1 inch above my part. My coolant will turn on, my spindle will turn on, and I'll have a spindle speed. Note, I cannot have 2 M codes on the same line because it is a miscellaneous function and it will not work. All right, so here we go. I've got the beginning of what I want to do. So this is how every tool will start. I'm going to go ahead and move my page up. So right now, to give you an example of where we're at, I have a tool, my 3-inch tool above my part, okay? Obviously the tool's not into scale. So right here, that's where I'm at. I'm 1 inch above the part. Now from here, I want to lower down, I'm 3 inches above it or 1 inch above it. I wrap it in, now I want to feed to Z0. Once I'm at Z0, I want to move my tool completely across the part. So that G code will be G01. That puts me into a linear interpolation mode, pretty much making straight lines, okay? I'm going to go Z0, and every time I have the initial G01, not every line, but the initial G01 when a tool starts, I want a feed rate. So I'm going to put a feed rate of 30 on there, and it's going to go into feed rate mode, so no more rapid. I'm going to go into feed rate mode to Z0, okay? So now here's where we're going to go kind of fast because I want to get this program done. So I'm going to move over off the part. So that will be an X plus move. My material is 4 inches plus 1.5 inches to go completely off the part. So that will be an X 5.5 inches. From here, I want to move up. So I will go a Y plus move, but how far do I want to go? I'm already taking off 1 inch off of a 4-inch piece. So I want to go up just enough to where it takes off, okay? So if I come back over here, I'll draw my tool. I've gone up 1 inch, okay? So if I come up, I'm going to take my tool and I'll go ahead and put it up here at the edge. And the reason why I'm doing that is because I know my profile tool will clean up any excess that I leave there. So I will simply come up from here. I'll come up, let's say 2.5. So 1 inch plus 1.5 inches equals 2 inches, 500 thousandths. So I'll go Y, 2 inches, 500 thousandths. And then I'm going to come back across my part to where I started, which was X negative 1 inch, 600 thousandths. Here's the best part. My facing is done. With these 1, 2, 3, 4, 5 lines we have right here, actually just like 4 moves, we have actually faced the entire top of the part. So now when I am done making a part, I want to send it home. Now there are lots of ways to do it in your books. I'm going to teach you a way right here that will work on every machine that you run on, okay? So I'm going to teach you this right here. Let me scoot up a little bit. I will go into rapid mode, okay? That means every X and Y move after this will be a rapid mode. G-O-Z 1 inch M08. I am now 1 inch above my part. Now I'm going to go G91, G28, okay? From where I'm at, home location, I want to go Z0, G91, G28, Z0. That sends me straight home where I'm currently at, The very next line will be G53. That is the machine's location. I'll explain that later. G53, G49, and then that's going to cancel off my tool length, and then I'll type in, and that should have been M9, I do apologize. Let's erase that. M08 turns it on, M09 turns it off. So I have that right there, and then the last thing I'm going to do is I'm going to put an M05. M05 will stop my spindle from turning. So GO, G91, G28, Z0 sends my machine home. Then at home location, it turns off my tool length and goes from there, okay? Here's the good news. I have successfully made my first pass. I got my first tool programmed, I safely started it, and now I'm going through and I'm gonna start running my profile. So the next thing I wanna do, if you'll remember, is right here below the green line, I want an M01. I want the tool description. I want to call up the tool. I want to position it at a safe location, and then I want to call up the tool length. I want the G43 on there. And then of course the G01. Okay, so that's all going to start happening like that. So let's go ahead and scroll back up. So the first thing I want in there is I want M01, and I want to go call up the next tool, and that next tool is going to be a 1/2 inch end mill. So on this 1/2 inch end mill, it's going to be the second tool that we run. It will be a tool 2. So T2, M06. Now remember, M0, because we're only allowed one letter O, and you're going to hear me say that a lot because that seems to be a common error that a lot of people will get. So T2, M6. The next thing I'm going to do is I'm going to go ahead and call up rapid G0, G54. Oh, sorry, that's not a 4. Let's go G90, G54. Now keep in mind, if I had typed in G54, GO, G90, as long as all those variables are on the same line, it will read it. So it doesn't have to be in a certain order, but they all have to be on the same line, okay? So I'm in rapid mode, G90, G54. Now on this one, let's kind of see where we want to put this tool at. So for example, I have a tool, of course it's a lot smaller because it's a 1/2 inch tool and it's not a 3 inch tool. Looks about the same size. But I don't want to start at X0, Y0, because when I come down, I will take out my part. Even if I'm feeding down to Z0, it will touch the top of the part. And if I feed below Z0, it will go across the part. So what I want to do, and the way I teach it, is I tell everyone to come off the part 1 inch total. So I want you to come off an inch in X negative. I want you to come down an inch in Y negative, okay? So what that does is it puts me in a safe location so that I do not come off the top of the part. This will help for visualization when you start programming your part. So what I'll do is I will go X negative 1 inch, Y negative 1 inch, and then again, I can turn on my spindle from this location. So let's go let's go 4,000 because it is a smaller tool. And M03, it will always be an M03 unless you're using a left-handed tool. So M03 will turn on my spindle in the clockwise direction, all right? So I have all my variables here. I'll go G43. I'm gonna go H. My H and my T have to match. You can put a 2, you can put 02, but you cannot put 20 because then it thinks it's tool 20's tool length. We'll go Z, 1 inch above the part, M08, okay? 8 turns it on, 9 turns it off. We just learned that. So now I'm in a good spot. I can go ahead and put my next line of code, which will be a G01. I will come down. Now here's the thing. I don't want to come down to Z0 because I'm not facing off the part. what I want to do is I want to come down 50 thousandths maximum depth of cut on this part right here, okay? So that means I have to do 3 passes around this profile for me to be at the correct depth. So I don't want to start at Z0. I want to start at my first profile depth, which will be a Z negative 50 thousandths, because now I am below the top of my part. So Z will be a negative 50 thousandths. Remember to put your decimal there, and remember that you have the numbers correct. The way I like to show people is to the 3rd place decimal. If you hide the decimal, that is 50. If the 5 was there, it would be 5. And if it was 500, it would be 500. The decimal makes you say thousandths. So that's how I have people learn, is by doing that right there. So then I need, this is the first G01 that the tool has read. So I'm going to put a feed rate, we'll say 50 inches a minute. Okay? So I've got my G01, I'm 50 thousandths below the top of the surface, and I'm at a feed rate of 50. Okay? So here's where stuff's going to get kind of tricky. So if you need to, pause and do a recap, because we're going to go over one of our first lectures, which is using cutter radius compensation. We have to turn it off if we turn it on, and in this case we're going to be moving more than the tool's diameter when we turn it on. Okay? So if you have not watched those lectures, I need you to go watch them right now. So what we'll do is I have my tool. I'm currently right here. So here's that rule of thumb I put on that last video, is when I turn on cutter comp, I am moving towards the line I am about to cut. I'm about to cut this line, okay? So I'm moving perpendicular towards the line I am about to cut. Now keep in mind, this is a dimensional line. It is not the actual part. So I am still in space. I'm not cutting anything. So on this line, we're going to go to X0. But because we are turning on cutter comp, X0 will put the tool right there, because it's going to keep it half the diameter of the tool away from the line to cut. That's going to take a little bit to sink in, so don't expect it to just happen overnight with your understanding, okay? Some people it will, some people have to watch the video a couple times. Don't worry. Just know that because cutter comp is on, I do not have to add a bunch of numbers everywhere. If my print says to move 3 inches 937 thousandths, that is what I'm going to type in, okay? So the first thing I want to do is turn on cutter comp, and I want to move to a Y positive 3 inches 937 thousandths. So let's start there. So I'm going to turn on G41 because I'm going to stay to the left of the line that I am cutting. Okay, that'll take some time to sink in as well. So G41 X0 D02. Now D02 is just like the H, and it's just like the T. So something to remember when you're using G43, you have to have the H on there. When you're using G41 or G42, you have to have the D. So remember, when you're typing these in, if you get an alarm, it's probably because you're missing one of those two variables. So I have successfully turned on cutter comp, I have gone to X0, and I've turned on the radius value. Okay, so the next thing I want to do is I simply want to move to Y 3 inches 937 thousandths. That has now put my tool up to the top of the part. The next thing we want to do is we want to go from that location to right there. Now keep in mind, I am at the pivot point on my profile. Now I have taught people in the past, it's always a good idea before you ever start programming to go through all your pivot points and write down the X and Y location of those pivot points. Now remember, those pivot points are in relation to your G54, okay? So that means that pivot point that I was just at in X is 3 inches, 937 thousandths, and it's gonna be up an amount right here, but we don't know what that amount is yet. So we have to figure out what that missing dimension is. So right here, my X value for this is going to be a known location in X, and I'm going to subtract this radius right here. The radius, I don't know what that is. It happens to be right there on my print. So that means my X location will be 3 inches, 937 thousandths minus 1 inch, 181 thousandths. So if we grab our calculator, we'll go ahead and type that in. So I'll type in 3 inches, 937 thousandths, subtract 1 inch, 181 thousandths equals 2 inches, 756 thousandths. Okay? So that would be the X location for right here. So I'll go ahead and I'll type that. I'll do that up here so it's a little bit easier to see. Let's get rid of this because we know what that is now. X is going to be 2 inches, 756 thousandths. And then my Y is where we already are at, because we are already there right now. We are already at that known location, which means my Y is going to be 3 inches, 937 thousandths. If I'm already there, I do not have to have my Y on that line, because my tool is only moving in X. Because it's only moving in X, you only have to put an X on that line. But if you have the Y on that line, it won't hurt anything. You just got to make sure that it is correct and that you don't get your numbers backwards, or else it will move to where you tell it to move. Okay? So I would recommend that you go print this off and make a separate piece of paper and write down the X and Y locations of all these pivot points before you even start. Okay? So all I'm going to do to keep it clean on my board is I'm only going to move, if I move in one axis, that one axis. So I'm going to move X 2 inches, 756 thousandths. Now remember, these are linear interpolation moves. They're all straight lines. So if you want to, you can put a G01 on every line. But G01 is what we call a modal mode, and that means you don't have to put it on every line. Once it's activated, it stays activated until you turn it off. Now remember that, because I'm about to make a G0, 3 or 2, and we got to figure out what that is. So we'll come back to our part right here, and you'll notice my tool is going to move from here to there. That is making a clockwise rotation move, and clockwise is G02. Now here's the cool thing. I was X and Y up here. My Y was 3 inches, 937 thousandths, but now it's an X 9 inches or 3 inches, 937 thousandths. And now my Y is smaller. So my numbers have actually flip-flopped. It won't always work that way, but it's good to get that idea that I'm going from a known location, subtract the radius, puts me at my next X and Y location. So I'm going to write that down, but before I do, once I complete this G02, I'm going to make a straight line, which means I will have to put a G01 at the beginning of the next line, or else it thinks that it's doing circles and will give you nothing but alarms, okay? So I'm going to put a G02. My X will be 3 inches, 937 thousandths. My Y will be 2 inches, same one as my last one, 756 thousandths. Now on a G03 or a G02 line, you have to have the R, and the R equals the radius, and the radius was 1 inch, 181 thousandths. So if I had left the R off, it would have made a straight line, even though it has a G02 on there, and it would not have alarmed out. However, if you put the R on there and not the G02 or 3, it will alarm out. So remember, they go hand in hand. If I have a G02 or 3, I have to have the R. So again, my next line will be a G01. And we're going to be moving down in Y, but we're not going to be moving negative. Okay, this is going to take a minute for it to sink in, but I am moving down in a negative motion. But remember, Y0 is this plane right here. So I am still in a positive quadrant. I'm still in a positive quadrant until I go into the negative quadrant. So all moves right here will be a Y negative motion. So we're going to move right there before the radius, because that is a pivot point. Okay, we don't start at the bottom of the radius. You don't put the 984 in there. We're going to have to put that right there. Now remember, this should be catching on pretty good now. I'm going to put the known location, which is my distance from here to there, and then I'm going to come up my radius, which is 312 thousandths. So I'll pull up my calculator and we'll type that in. It's going to be 984 thousandths plus 312 is going to be, that is my Y location. Notice how it is in the plus direction. That is how I will plug it in. So G01, Y, 1 inch, 296 thousandths. You have to get this number right within 1 thousandths, and your swing value on the G02 and G03s within 1 thousandths, or it will alarm out on you. You cannot round to the nearest 10 thousandths. Okay? So the next thing I'm going to be doing is I'm also going to be swinging a radius, but are we swinging a G02 or a G03? So I will draw my tool, and if you'll notice, I will be swinging in a clockwise direction around my part. So right there, I'm going to be swinging around my part, and then I can see that I'm going to be making another straight line, and I got a pivot point right there. So that's where I'm going to be stopping. So what I need to do is I need to figure out, I know what my X will be. My X will be 984. I'm sorry, my Y will be 984, but my X will be a known location from where I was currently at minus the radius of that right there. So let's find out what that is. So I'll type in where I was currently at, which was 3 inches, 937 thousandths, subtract 312 thousandths equals 3 inches and 5/8, 625 thousandths. So we're going to be swinging a G02. My X will be 3 inches, 625 thousandths. My Y, we had that known location on the blueprint, was 985 thousandths. Make that more like a 9. There we go. So I also have to have what on here? If I have a G02 or G03, I have to have the R. The R has to match what it was on the print. Okay, you can't put 1 inch 181 for every radius. So this was 312 thousandths. Now I was in a G02, which is a modal mode. Now I have to go back to a G01 modal mode. I'll be making an X move. So let's find out where I'm going to be putting myself. So that's where I was. Now I'm going to move to my next pivot point. My next pivot point in X will be 1 inch 969 plus the radius of my radius, okay? Or plus the dimension of my radius, which is 312 thousandths. My Y will not change, so my next line will simply be an X positive move because I'm still in the X positive quadrant. All up here is positive, positive until I go into the negative, negative quadrant. So right there will be 1 inch 969 thousandths plus 312 thousandths, 2 inches 281 thousandths. So my X will be 2 inches 281 thousandths. Let me make sure I type that in right. Very good. So after this line, I'm going to be making a G0 move, but let's find out if it's going to be a 2 or a 3. So I'll come back here. If you'll notice, now I'm swinging the other direction. I am making a counterclockwise motion, which will be a G03 move. So we know what the X is going to be. The X is on my print, but my pivot point for this position will be 984 thousandths subtract the radius because I'm going here to there. So I'll go ahead and type it in. 984 thousandths subtract 312 thousandths equals 672. So that's what my Y will be. So again, I'll be swinging a counterclockwise rotation, and then I will be going to X 1 inch 969 thousandths, and then I will be doing a Y of 672 thousandths. Notice how I'm still in the plus area, and I have a G03, and a G03 needs the R, 312 thousandths. I know my next line is a straight line, so I can go ahead and put a linear interpolation modal mode code. At this point, it gets pretty easy. I'm going to move my tool from right there to Y0. Now remember, without cutter comp on, that is Y0. On your offsets in the diameter column, if you have nothing set there, that is also Y0. You have to have cutter comp on, and you have to have your column set correctly, which I will show you. So when I type in Y0, it will move to the center line, and then it moves, it offsets, cutter compensates half the diameter of my tool. So when I type in Y0, it will put it at the right location. So I know my next move will be Y0. I'll move this up so we can see a little better. Now in here, I'm already at this bottom area, and what I teach is I want everyone to go back to where they started. This is going to be a closed loop profile. That will make sense, and it's very helpful once we get going. So I'm going to move all the way over here back where we started, which was an X negative 1 inch. So I went all the way off the part, a negative 1 inch. So now I'm going to go X. Notice I didn't put a G01 on there because I'm making another straight line, and linear interpolation is already active. So X negative 1 inch, and then I got something else going on here. I'm going to put it back to Y minus 1 inch. Okay, but I'm missing something there. So what I got to find out is what I'm missing, because I'm going to turn off cutter comp. And in order to turn off cutter comp, if you'll watch the video before, I have to turn it off moving away from the line. Sorry. Well, I'm having a hard time here. I apologize. There it goes. So I have to move away from the line I just cut. So I just cut this line, and then I'm going to turn off cutter comp, moving perpendicular away from the line I just cut. So therefore I moved of Y negative 1 inch. And then I'm also going to be going G40. G40 and the Y need to be on the same line because you want to move the diameter of the tool while moving away from the line you just cut. So here's the good news. All this code that we just did, that's a lot, okay? So if you need to, you can take it back and watch it again. But if you'll notice, we did all of this code, this profile, at a minus 50 thousandths, okay? So at this point, you can take this and pop it into your simulator and see if it runs correctly. If it runs correctly, you can move forward. What I'm going to show you by moving forward is I want you to make this closed profile 150 thousandths deep, but I still have to go around it 2 times. So I don't want to write all that line of code twice. So here's where using a computer comes into play. So from here all the way down, and I'll make my line a bit longer, to my G40, I can copy and paste, and I can put all that right below my G40. And then all I would do is I would change the Z negative 50 thousandths. Now remember, we're absolute. We're in G90 mode, okay? G90 mode means it's how far away I am from Z0. I won't go an additional 50 thousandths. I'll go down to a negative 100 thousandths, which is another 50 away from the top of the 0, okay? That might take a second to sink in. So I'm going to go a minus 50 thousandths, run the profile, and then I will copy and paste again, and I will change that to a 100 thousandths. So I was almost there. So right here. So I would paste my negative 100 thousandths, and then I would paste again, and I would do a negative 150 thousandths. So by doing that, I have now made my profile 150 thousandths deep. Again, you'll have some excess material that you'll have to take off of there. The next thing I want to do is this tool is done. So again, when a tool is finished, I want to send it home. So I'm going to go in GO, Z 1 inch above the part, and we're going to turn off that coolant, which is M09, and then we're going to send it home the universal way. But here's the thing. Am I done using this tool? Because if I was done using this tool, I would type in a G91, G28, Z0, G53, G49, M05. If I was done using that tool, okay? But here's the thing. I'm going to use that 1/2 inch tool to go around my pocket. So I'll take my tool, which was right there, and I'm going to position it right there. So I'm not going to send it home. I'm just going to come 1 inch above the part, and then I'm going to move to this location right here. However, this location, this will make a lot of sense as you do it, is going to become my new origin. but it can't be G54 origin, okay? It has to be a different work offset origin, okay? Which is G55. So G55 is now the center of my pocket. So which means whenever I turn on cutter comp, I simply have to move the exact amounts that I want to move and it will work out just fine. So with that said, let's go ahead and go back to our code and adjust it accordingly. So I'm going to erase because I don't want to use it yet. I don't want to send it home yet. Okay. I want to go to the next tool or the next work offset. So I'm already in Rapid, but I usually type it in anyway because it's a good habit. GO, G90, wasn't very good. G55, okay? X0, Y0. If I did not give my G55 the work offset and put it in the center of the part, you would have to add the difference from origin on G54 to the center of the pocket and then add that to your move. And it can get confusing really fast. By doing this, it lowers the confusion and it really does make it easier once you get used to it, okay? Once you get the hang of it. So right now I have put my tool 1 inch above the part and I put it to G55 XY0 in the center of that pocket. So from here, I want to go ahead and draw my tool. Now remember, this is the second lecture that we went over. This lecture is how to ramp safely into the part. So what I mean by that is I want to grab this tool and I'm going to zig, zag into my material. And as I'm zigging, zagging into the material, I'm only cutting with the edge of the tool because I can't plunge straight down. So watch that video if you need more explanation. So on here, I'm gonna feed linear interpolation, G01 to Z0, and I'm gonna zigzag, and then I'm gonna go ahead and make 2 small squares, and then I'll make my finished profile, okay? So what I'll do from here is I'll go G01, Z0, that's the top of my part, and let's feed at a feed rate of 30, okay? Then I'm going to go zigzag, which means I'm going to move more than half the diameter of my tool. So I'm going to go X, let's just say 300 thousandths, and then I'm going to lower down in Z a negative 25 thousandths. That's my zig, okay? You do not have to write that on your program. It's just for visual reference. And I'm going to come back to X0, which is the center of my pocket now. And I'm going to go down another Z negative 25 thousandths, but because we're in absolute mode, it's going to be my zag. I am now 50 thousandths. I'm absolutely 50 thousandths below Z0. So that means X0 back there. So now I'm 50 thousandths in my part. I'm safely in my part. Now I'm going to start making my pocket. So what I'm going to do is, because I've already got my tool and I know that I can safely move 300 thousandths, I'm just going to go 300, 300, 300, 300 back to 0, and then I'll move a safe distance over. I'm going to say 5/8 will work out pretty good, okay? So I'll go 5/8, 5/8, 5/8, 5/8, 5/8, and then I'll be done, okay, with my pocket. So let's move up my part, because we know we're 50 thousandths in the bottom of my part. And then I'm going to start going X 300 thousandths, Y 300 thousandths, X negative, because I'm going into the negative quadrant now, 300 thousandths, because the center of my pocket is XY0. So if I'm on the left side of the pocket or the bottom side of the pocket, I'm in the negative quadrants. So then I'll go Y negative 300 thousandths, and then I'll come back to X positive 300 thousandths, and I'll come back up to y0. Okay, so that was quite a bit, pretty fast, but it's pretty simple. Okay, all I did was make a 300 thousandths square, and now I'm going to make a 5/8 square. Okay, so now I'm at y0. I'll go x 0.625, y 0.625, x negative 0.625, y minus 625 thousandths, x positive 625 thousandths. I'm going to go back up to y0, and then before I turn on cutter comp, this usually keeps me from getting any alarms. I'm going to move back to the center of my part. So once I move back to the center of my part, I have already made a 300 thousandths square, a 5/8 square, and then I have returned back to 0. Now I'm going to turn on cutter comp, which is G41, and then I'm going to go around this part. However, before I do, this would be a good time to stop and plot the pivot points on this part. Okay, the good news is my part is the same dimension wide as it is tall. So I'm going to grab two numbers and I'm going to plug them in on my whiteboard because I'll need these two numbers as I go around the part. This is where it gets kind of tricky. As I write them down, you'll have to try to keep up with it, and if you can't, just rewatch it and you'll get that understanding. So what I'm going to do is I'm going to turn on cutter comp, moving perpendicular to the line I'm about to cut, which is this one. So cutter comp on, and then I'm going to move to my first pivot point. So that first pivot point is going to be 1 inch 968 thousandths divided by 2, because all I want is that distance, because this is where my origin is right now. So that distance, and then I subtract the radius, okay? Because from here to here, from here to there is that divided by 2, but I'm not moving all the way up there. I'm moving about right there. So what that means is I'm going to have to take that number divided by 2, and I'm going to have to subtract the radius. So 1 inch 968 thousandths divided by 2. Okay, 984 thousandths. I want to write that number down. I'm going to write down 984 thousandths, okay? Because that's going to be the top of my pocket, the far left of my pocket, the far bottom of my pocket, and the far right of my pocket. So what I'm going to do now is I want to find out the next number, which is that minus 312 thousandths. 672 thousandths, 2 tenths, and 5. Okay, so you do not have to plug in all the way to the last decimal on here. I want you to go to the third place decimal when you're using the simulators. You're less likely to run into error, because if you type in too many numbers, you can go to the fourth place decimal if you want, but if you go to the fifth place decimal, it will alarm out. Okay, so from here, I want to write down 672 thousandths. So from here, let's turn on cutter comp left, which is G41, and then we're going to start moving to the right locations, okay? Keep in mind what quadrant we're in, and also keep in mind what radius we're swinging. Are we swinging a G02 or a G03? Let's find out. So we'll move this up. Right there looks good. So cutter comp G41 X. I'm going to move all the way to the side of the pocket, which is 984 thousandths. So remember, G43 needs the H, just like G41 or G42 needs the D. So I'm going to put a D, and if you remember, this is still tool number 2. I used D2 at the top. I will also use D2 right there. And anytime I'm using the T2, the H2, the D will also be 2. Okay? So now I've turned it on. I'm in G41, I'm still in G01 because they're both modal modes. I'm going to move to my first pivot point, which will be a Y 672 thousandths. So Y 672 thousandths. Notice how I have my decimals on everything I do. I want it to be there. I don't want to have to mess up, okay, or have to go back and fix something. Okay, so right now I'm going to swing, I'm going around the pocket like this, which is a counterclockwise move. So G03, now I'm going to have an X. Now my X is no longer going to be 984 thousandths, it's going to be 984, subtract the radius, which we already know that answer is 672. And we're still in the positive quadrant in X, so it will be 672, because it's just a smaller X value. And then my Y will go all the way up to 984 thousandths. And my G03 needs an R. Okay, so now we're just going to go around the pocket doing that right there. Remember, I want a closed profile so I can start dropping into my pocket. So now I'll go G01. I'm going to move into the negative quadrant now, which will be a negative 672, because I'm not all the way to the side, I'm to that pivot point. I'll do a G03, which will be an X negative 984 thousandths, and my Y will come down from 984, but I'm still in the positive quadrant, so it'll be 672 thousandths. If you have 984 thousandths on X and Y, or 672 thousandths on X and Y, you got something wrong. Okay, that's a quick visual. And then I need my R, 312 thousandths. Okay, that's my radius. G01, because I have to go back into linear interpolation. I'm going in the negative quadrant, okay, which is Y negative to my pivot point, 672 thousandths. Then I'm going to turn on my G03. My X will go to a negative 672 thousandths, and my Y will go all the way to the bottom, which is a negative 984 thousandths, and I need an R right there. So the next thing I'm going to do is I'm going to go all the way back into my positive X quadrant, which will be a positive 672 thousandths. And then I'll do another G03, which will be an X 984 thousandths. My Y will go still in the negative quadrant, but it's not as big as a negative 672 thousandths, with an R of 312. And then the last thing I'll do is I'll come up G01, and then I'll come up to Y0. That really completes my profile. So let's move this up, or not my profile, my pocket. So here's the thing, cutter comp is on. If it's on, I have to turn it off, and when I turn it off, I have to move perpendicular away from the line I just cut. So let's come back here. We started there. We turned on cutter comp. We went all the way around. We're right here at Y0. Now we're going to turn off cutter comp, moving away perpendicular from the line I just cut. So I'll go G40, X0. So now that I have turned off my cutter comp, I have moved to the center of my pocket. I have successfully made a closed loop pocket. So from my G40, or I'm sorry, not my G40, from my zigzag. So there's a lot of code we got right here, okay? So right here, from my zigzag, okay? Once I run it through the simulator one time and it looks good, I am good to start copy and pasting. So because remember, at the very end of my program, I moved to Y0, X0 and turned off cutter comp. At this point in time, I can zigzag, but my numbers will be different. I will go 75 thousandths, 100 thousandths. That way I'm 100 thousandths deep into my pocket. So to keep on moving this up, I would take all of this, and we'll go ahead and, for visual purposes, we'll grab my line and keep going. There we go. Right there. I would copy all that code and I would paste it right below here. Okay? So I'll just paste. And then my Z would be a negative 100 thousandths. Then it would go a Z negative, I got my decimal in the wrong spot. Let's get rid of that. 150 thousandths, but the next question is, how deep is this pocket? So when I'm looking at my print, I gotta make sure to have all the identifiers here. So if I look at the print, I see that my mill profile, is 150 deep, but how deep is the pocket? In this case, it's 196 deep. So I'll go 50 thousandths, 100 thousandths, 150 thousandths, and then I'll just go, it's 46 thousandths more deep, but from 0, it's a bigger negative, okay? So that means it would be Z negative 196 thousandths, okay? So now we are done using this tool. I'm ready to send it home, okay? Because there's nothing else I can use this tool for. So I will go into Rapid. I will go 1 inch above the part, and I will turn off my coolant, M09, and then I will do my safe home return, which is G91, G28, Z0, I'm telling it to go in Z0 only, and then I'll go G53, I'll go G49, this cancels my tool length, and then I'm going to stop my spindle, okay? So now I'm ready to do my last 2 tools, okay? So let's move this up. So to recap, I have faced my part, I have profiled my part, and I have pocketed my part. And I have ran all this through my simulator to make sure it was all right before I keep continuing. Because just like any software program you use, once you create a feature, you want to simulate so you can get all the errors out of that one feature instead of making the whole program and having a list of features you have to fix. It's going to be a lot easier to do if you do it one at a time. So what I have to look at next is my holes. Now here's where the holes get pretty easy. Obviously, there's certain commands on certain machines that make it easier, but we're going to do it the way that works for everything, which is we're going to trig out the locations of the holes. Now you think trig, you think, oh, this is going to take a little bit. But the way I teach my students is there's always a fast way to do it. And that's what I want to teach because I want to get things done. We're in a high production situation. I want to get these parts programmed and on the machine. So first thing I'm going to do is I'm going to get my tool ready. So that was the last tool that happened. I want to put an M01. My tool description will be a number 3 center drill. Okay. And then I'm going to go ahead and call up the location of everything. So I'm going to call up my tool, T3 M06, Rapid for G0, G90 for absolute, G54 for work offset, and then I'm going to go to, oh, it's not going to be G54 though, we're going to go to the center of our pocket. So that's going to be G55. G55 will be the center of my pocket because that's where I want to start or that's not where I want to start, that's where I want to put my work offsets, okay? Now here's the thing, if I go X0, Y0, we'll turn on our spindle, we'll say 2500, and we want to turn on our spindle in the clockwise direction, okay? So right now, we want to go through and trig out our holes once we move down 1 inch above the part. So I'll go G43, H and T have to match, Z 1 inch above the part. So let's go back to our print, let's start doing some trig. So here's what I'm looking for. What I'm looking for is a radius value of my bolt hole circles. So obviously the diameter is all the way across, but what I need is a radius. Now you might get lucky and it will be on the print, okay? That means that is the distance to all the radiuses. Well, in order to do trig, I have to create a right triangle. There's my right triangle. I know my hypotenuse, my little c, okay? Now I have to know my big A angle, or I just have to know any of the other sides, of course, for a right triangle. But in this case, finding out my angle is going to be a lot easier because I know that it is a 360-degree bolt hole circle, and I know how many circles I have in the bolt hole circle. So why does that make it easy? Because I have numbers already there. So let's pull up our calculator and we'll say 360 degrees divided by how many holes I have on my bolt hole circle, which in this case is 8. I hit equals. That's a 45-degree angle from one hole to the next. So now that I know my big A, so now I'm going to do my trig a little bit quicker. So what I'm going to do is I'm going to come down to a trig calculator, okay? So we already wrote down on here that my hypotenuse, my little c, is 787 thousandths, and my big A is 45 degrees. So on here, let's see if I can give it to me. On here, I'm simply going to come to my areas and I'm going to type in little c, which is 787 thousandths, and my big A is 45. I hit calculate, and now I have little a and little b known on those areas. And I'm lucky because guess what? They're both the same number. They're 556 thousandths and 4/10. Well, I'm going to round down, okay? So that way 556 is going to be my same number all the way around. That makes it a lot easier, okay? So let's come back to my print, and I'm going to type in that 556 thousandths all the way around my part. So what I'm going to do is I'm going to type in my drill can cycle. Now this is the third lecture where I go over how to do certain hole patterns along with the trigging of hole locations. So right now we are in the third lecture on how to make this part. So on my drill can cycle, if I look at it, I want to start with a G81 because I'm center drilling. I'm not doing a deep hole. I'm just going to center drill. So on the center drill, on a G81, I need 3 variables after the G81, which is my Z depth, which will be a negative value. I want an R, which will almost always be 100 thousandths above Z0, and then I need a feed rate. And for a feed rate, I'm going to put 20. So 20 inches a minute is going to be my feed rate. So my Z, well, how do I find out my Z? Normally, it depends on your center drill and how far deep you want to go. For this example, I'm just going to go a little bit past how far I need to go. So I want to go 50 thousandths. I'm going to see if there's a number I can round up to. So if I'm looking at the depth of that pocket, it's 196 thousandths deep. So if I want to go 50 thousandths past that, it's going to be 246 thousandths. Well, I can go 250 and just round up, and that gets me pretty close. I mean, I'm not wasting any time. I'm not doing it wrong. I'm just doing it a little bit faster, okay? So my Z will be a negative 250 thousandths. You can go as deep as you want on whatever size center drill you're using. Just make sure that you're not violating the diameter of the hole by going too deep. So here's the next thing I want to look at. A G81, when it reads it, no matter where it's at, will execute that line. Well, I'm currently in the center of my pocket, but if you look at my print, I don't have a hole in the center of my pocket. So I don't want to be in the center of my pocket when I first run it. So there's two ways you can do it. You can either go in a clockwise motion around my part, or you can do all the easy holes and then come back and do the 556 thousandths. So I'm going to go ahead and do just one at a time in a clockwise motion. And if it makes more sense to do it the other way, that works as well. Okay, so I don't want to go to X0, Y0. Okay, I do want to be at Y0 because Y0 is right there, which is directly across from my origin. But my X is a 787 thousandths in the positive direction. So 787 thousandths in the plus direction. So now when it reads that line of code, it will come down and put a drill point or a center drill right there. So now let's go ahead and get around my pocket. Let's get all those holes in there. So the next location will be an X 556 thousandths, Y 556 thousandths, because I am in the plus quadrant. Once I type that in, I'm done. So it goes in there and pops another center drill because G81 is a modal mode. So then my X will become 0 and my Y will become 787 thousandths. Because I'm coming to X0, Y, the radius of the bolt hole circle. So that's why it's also good if you want to plot the hole locations of your bolt hole circle before you start going around, just in case it makes it simpler. So then I'm going to be in the X negative quadrant, and the Y I'm still in the positive quadrant, 556 thousandths. And then I'm going to go to, again, X will go negative 787 thousandths, but now my Y is back at 0. So I went top, not the top left corner. I'm in the far left, okay? So X negative and Y is 0. The next one will be a negative location. So 556. Y will be a negative 556. And then I'm going to move from here down to the bottom, which will be X0, Y negative 787 thousandths. Okay, I'm kind of getting my numbers a little jumbled up, but it is Y negative 787 thousandths. And then I'm going to come from here over there. So let's move up a little bit. I will go X 556 because I'm in the positive X quadrant. My Y will still be negative 556 because I'm in the negative Y quadrant. So here's the thing. Now I have cut all of my holes, okay? I've center drilled them. So I'm done with this tool. I want to turn off the G81 can cycle, which is a modal mode. So I want to turn it off with a G80, and then we're going to simply send the tool back home because we're done with it. GO Z1 inch M09, and then we're going to go G91, G28, Z0, and then I'm going to go G53, G49, M05. So here's what's really cool. I've done the drill can cycle. I've got all my locations. I would simulate it, and if it looked good, now I can copy and paste again, but not to run the center drill again, but I'm going to run the drill, but the drill goes to the same locations, except the Z will be different, the T and the H will be different, and then I will probably use a G83, so I'm going to put a Q on the line. So 5 more variables will be added or changed after we copy and paste. So, for example, we're going to pretend that I just center drilled everything, okay? So the next thing that would happen would be the drill would run. And we got to find out what the diameter of the drill is. So on here, I'm using a 125 thousandths drill, but this GD&T symbol for diameter, that's what I want to pay close attention to. That doesn't mean the drill tip goes down 196 thousandths below the pocket surface. It means the diameter of the drill goes down 196 thousandths below the bottom of the pocket surface, okay? Because if you'll notice, that's how deep it is to my pocket surface. That's how deep this diameter needs to go below that surface. So I'll do some calculations real quick while I'm here. I will do 196 plus 196, okay, equals. That's how deep the tip of my drill is going. But again, I want the diameter of the drill to go deeper. So in this case, I would do the diameter times 0.3, which gives me 37 thousandths, or I could trig it out to get the answer. So I will simply add an additional 37 thousandths. So that means my overall Z depth from Z0, the top of the part, will go down 429 thousandths. So I'll come back to my part program, and I will put that in there. I like my spindle speed. I'm not going to change that. I like my X and Y start location. I like that. So this is a 125 thousandths drill. And then from here, I have to change the T and the H. So this will be tool 4, and the T has to match the H. And then from here, like I said, we got to change that Z, which is going to be a negative 429 thousandths. And then I said we're going to change this to a G83. And a G83 will need 4 variables, and we said that variable would be a letter Q. So a letter Q is how far the drill pecks into the part, okay? That'll look a lot more visually correct when you start watching in the simulation or on the parts, okay? So what it does is from the R location, it will go down Q, R, Q, R, Q, R. The R stays the same, the Q takes it that much deeper each time until it reaches the Z depth. So I'll put 100 thousandths. That looks pretty good. So now, all I did was change those few little areas, and all of a sudden, I have my drill can cycle already done. So I copied and pasted, and on that second paste, I went ahead and changed everything, okay? So now I have my facing, my profiling, my pocketing, my center drill, my drill. So at this point in time, I'm at the end of my program. So every program ends with these 2 areas right here. I've sent it home, my coolant's off, my spindle's off, I've canceled my tool length, everything's in a good safe spot. I'm going to give it an M30, and then when the machine starts reading that percent sign at the very top, it has to have a percent sign at the very bottom. That's how it knows to stop reading, okay? So that means once that percent sign's at the bottom, it doesn't read anything below it. It also doesn't read anything below the M30, okay? The M30 resets and rewinds my code. So if I have an M30 and then I start putting code below it, it won't read it. Even if it's in between the percent sign and the M30, it will not read the code after the M30 when running the program. So something to think about. So I know this was quite a bit. I said we were gonna run through the simulator. In all reality, you're gonna run it through the simulator to see how everything works. So just remember to take your time, use your programming workbooks, watch this video. I know it's an awfully long video, okay? But what I'd like for you to do is try to break it up. Just watch a section at a time of this video until you get that understanding on how the profile works, how to start that part, how to start the part right, okay? There's a lot of things going on this part, and it's best to just take your time, one feature at a time, to see if it's right, okay? So again, this is how to program a mill part from percent sign to percent sign. My name's Aaron Runk. Hope this video helps you. Please come see me if you have additional questions, or if you can, refer back to this video for questions that you have. Thank you for watching, and good luck.